Hello and welcome. I'm Adrian Sanabria, host of the Enterprise Security Weekly podcast and founder of the Defenders Initiative. Welcome to this webcast sponsored by Minimus. I have two guests with me today. Patrick Maddox, VP of Solutions Architecture at Minimus. How are you doing, Patrick?
I'm doing great. Thanks for asking. Thanks for having us on.
Yeah, looking forward to the conversation. We also have with us Neil Carpenter, Field CTO at Minimus. How are you doing?
Hey, doing fantastic. Looking forward to talking today.
Looks like you have some interesting stuff hanging behind you there. Maybe a dulcimer and a mandolin, something. It's blurred,
right
but
on both counts.
Yeah, I'm taking that as a challenge. Like I'm trying to unblur it with my brain. All right. Today we are talking about moving away from endless vulnerability triage towards real risk reduction. If you have any questions as we go through this, I imagine a lot of this is going to be really relatable for folks, especially if you work in vulnerability management. Feel free to drop any questions you have into the comments, and you can put in a comment using that first blue bubble down below. And yeah, that is the main way that you have for chatting with other attendees or chatting with us. I will be checking that throughout, and I generally prefer we pull in questions within the context of the conversation rather than saving them all for the end. No guarantees we'll have time at the end to answer them. So if you have any questions, get them in. Also be nice to hear where people are joining from and whether or not you're directly dealing with vulnerability management, if that's a pain point for you, particularly in the container space. So with that, let's jump into the conversation here. So I hinted there that we do have some context for this vulnerability discussion, and it is containers, correct?
Yeah.
All right. So yeah, jumping into it here. Yeah, I was having a conversation just earlier today that was also live and in front of an audience, but we're talking about use of AI to discover and define vulnerabilities, and whether or not we're going to see the number of CVEs increase massively, because we can now use more automated tools to find some of this stuff. And already we're looking at something like 20,000, 25,000 CVEs per year. I imagine that's going to mean even more noise. So, Neil, just from your experiences, I imagine that you're customer facing, you have a lot of conversations with folks. What are people dealing with regarding vulnerability management today? What kind of challenges are you seeing the most?
Yeah, and I think the increase in CVEs is one of them. I'm not sure. We see like Daniel Hacks, is it, who writes curl, talked about this recently, that he's getting a flood of vulnerability disclosures that are obviously AI generated and aren't very useful. I think we're going to see a lot of that, but the number of CVEs has been growing year over year anyway. Everything is now software. Lots of researchers are looking at things. We don't need new tools to increase the number of CVEs. We already have that happening year over year as it is. And I think also certainly the issues with NVD that we've had in 2024 and 2025 are still causing pain where we don't have CPs. We don't know what vulnerabilities are attributed to what packages for every vulnerability that's out there. We don't always have severity data. That stuff is lagging behind. I used to joke that I hadn't talked to an organization who was happy with their vulnerability management program. And I think for the ones who are serious about it, that's where they all are. They are all trying to manage more volume, more vulnerabilities, and doing it in particular. Patrick and I are in the container space. In the cloud native space, an interesting thing has happened, which is that the vulnerabilities are the same. And I use, let's use Tomcat as an example. It's a Java web server. If I have a vulnerability in Tomcat and I'm running it on-prem in a couple of VMs, or I have a vulnerability that is in a container image and I'm running on Kubernetes on AWS, The impact of that is the same. If it allows for remote code execution, somebody can exploit it, maintain persistence, do recon, break out of that, go whatever, right? Do what we know attackers want to do. What's different is how I fix it. So in my on-prem data center, I might file a ServiceNow ticket. Somebody comes along at 2 a.m., patches stuff, reboots them if they need to, off we go. I can't patch running containers, right? Somebody pedantic in the audience is going, yes, you can, Neil. Technically, but it's not useful. It's not how I need to solve the problem. What I have to do is go back and get a developer to fix the image that all of my containers are based on, retest it, reship it, and then redeploy all my containers based on it. So while I've got the same risk, the same set of problems, I have a different set of constituents involved in doing that. And so security teams over the last decade, but it's significantly less time for most of them as more and more organizations have embraced these technologies, have had to wrestle with how do I manage this completely different set of constituents, this different approach to fixing it. And that's led to a lot of friction, a lot of difficulty, a lot of pushback on, security teams are going, they're scanning things that are being deployed. And they're like, well, you've got critical vulnerabilities, high severity vulnerabilities. You've got to fix these. Developers are coming back and saying, I have other work I have to do. You're sending me 100 vulnerabilities. This is a ridiculous amount of work. I don't even use 3/4 of this. Actually, 3/4 is low. I don't use 99% of these things you're sending me vulnerabilities on. Why should I patch them? There's all this friction that's happening in that system. And so to sort of complete my joke, I have now run into one or two organizations that are perfectly happy with their vulnerability management situation, but it's because they're not doing anything. They're quite literally, I talked to one organization who's like, well, we run apt-get update, apt-get upgrade once a month, and we've got it handled. And I was like, ooh, I'm so glad I don't have any data in your company. But okay, cool, you're happy. That's
ignorance is bliss. Yeah, the more you dig into it, the more you're concerned. We didn't even mention the supply chain attacks and stuff like that. Like, somebody edits a post-install script on an NPM package, and all of a sudden that gets a CVE, right? All those getting malware built into them and stuff like that. Like, it's not even a bug in the software technically, So we also have this kind of debate of like what justifies getting a CVE versus it's kind of frivolous and just generating more noise.
And there's another argument around cloud services. If I find a vulnerability in a cloud service,
right,
do I need a CVE for it?
If a service provider fixes it once, do we really need a CVE? Because typically CVEs how we communicate remediation, right? But there's no remediation when AWS fixes it once across all their services, right?
Yeah. And I've got my own opinion, but it's an ongoing debate, I know.
And kind of tackling the problem space here, Patrick, I want to come to you from more of a design and architecture standpoint. Where do you see a lot of the mistakes here? What are things that people should be doing to kind of alleviate some of this pain on the front end?
Well, so I think this is sort of, Neil alluded to it and kind of talked a little bit about it, but the reality is for most applications deployed into a containerized environment, it's the same bits and same software that was largely just sort of lifted and shifted from the sort of thick operating system VM days. And it's just, the rush to use containers and use some of the advantages that containerization brings. I think fundamentally you're still dealing with the same software, the same bits. And the approach was largely to try to drive maturation of the infrastructure over the last 10 years. And now we're really in a place where tools like Minimus, and you can take the approach of having fewer things in your container images to start out with. And really, the approach I think that you look at is why even have those packages available in the images architecturally if they're not functionally going to allow you to ship any software faster. If all they do is drive a lot of behaviors that cause operations teams and development teams to chase their tails, worrying about vulnerabilities that really kind of don't add anything to the picture of delivering product to your own customers faster, why even have them in place? And so taking an approach of just not having those packages present really kind of allows us to really kind of sidestep some of it. Because we talked a little bit about it. Finding vulnerabilities is not a challenge. I mean, I think we're in a place where you can discover at least known vulnerabilities trivially across a variety of open source and commercial products. That's not a really an unsolved problem at this point, where early in the containerization days, it really was. There weren't any tools built to look at containers and everything else. Now we've kind of gone through this last 4 or 5 years where prioritizing what you find in combination with other aspects of your environment has really been a lot of the focus of tooling and industry and customers. But we found that really hasn't reduced the vulnerability problem in and of itself, because the incidence of vulnerabilities is sort of outracing your ability to prioritize against them. So really the kind of strongest thing that I think you can do is just sort of fundamentally change what you're putting out into production and what you're developing against, to make sure that, you reduce in the surface. And really one of the only practical ways was just not having those bits present that could be exploited.
Yeah. And just to highlight some of what you're saying there, I should have grabbed the name of the report for this, but the Scientia Institute has some great reports on this. They did some great work way back in the day with Kenna, which was acquired by Cisco, very focused on prioritization. That basically found that less than 1% of vulnerabilities are ever going to be any kind of real risk to your organization. So we know that prioritization could be useful here if you can make it work, and that's kind of an ongoing challenge that we're seeing, kind of a different conversation. But they also found that enterprises only patch about 10% of vulnerabilities that they discover, and I imagine what are some of the reasons for that? I think Neil, you alluded to it. People saying like, I'm not even running this software. Where'd you get this? Or and maybe it's installed in the environment, but it never gets executed. It's not actually being used.
And I love that Scientia report. There's a great scatter plot in there that shows that 10% is constant across org size, like 100 new vulnerabilities found a month versus 10 million. And it's just a constant, like some are hitting 12.5, some are hitting 7.5%, but it's just a band all the way across. And yeah, I think there are a number of problems that happen there, right? And the first one is just this friction, especially in the cloud native space, of having people who are responsible for fixing these things, who are also responsible for features and bugs and sort of all of this other work. There's a natural tension, especially as we have so many vulnerabilities found in the things that we're shipping and running. To just go, look, I don't know what you expect me to do with this. I can go through and tell you I'm not using any of this. I'm not using any of this. And it just becomes bogged down in that. And it becomes very hostile and very difficult to manage. And so, I think like Patrick, obviously, I believe reducing what we're putting into that system is one piece of that. But I actually think, practically speaking, there are 3 things to do that start addressing this. And the first one is prioritization. And I'm ordering these sort of in the order the industry's gone about it, rather than where I think we should start. But prioritization is a big one. If I'm not prioritizing and I can only fix 10% of my vulnerabilities, then the Venn diagram of what I fix and that 1% that might actually be exploited, if I'm lucky, are 2 circles that are barely touching, right? So prioritization is saying, let me go look at, on one side, what is exposed? Where am I running things that are actually can be reached? Reachability is the next piece of that, which says, can I get from the edge? Is this actually something that I can run, actually runs inside of this container, this VM? I look at, crown jewels, what's important in my environment. Let me focus on where things are important, where I have an attack path to get to something that's important. Focus on exploitability, which vulnerabilities are known to be exploited, which ones are likely to be exploited. Like, all of that helps.
And what does exploit even mean? right? Does it
Yeah.
make the software crash? Does it give you a shell? Can you execute code?
Well,
Is it privilege
and I
escalation where you already need to be authenticated?
yeah, and I think that's where there are lots of approaches to that, and you're touching on sort of my academic monomania, if you will,
Mhm.
because yeah, I mean that's typically you in practice you're combining CVSS score for how bad could it be, and that's an important caveat on CVSS. CVSS, the score associated with a CVE is not how bad it is; it's how bad it could be. And so you'll
That's a
see
good way of putting it.
vulnerabilities that are really edge cases that they're very unlikely to be exploited and very difficult to exploit. But if you manage to exploit them, and if they're in a particular configuration, whatever else, they're incredibly damaging. So they're critical, even though they're very unlikely to actually be exploited. You're very unlikely to be in the situation where it's exploitable, et cetera. Combining that with something like EPSS, which is a measure of how likely is this to be exploited, is where I think a lot of companies start with the prioritization. So I've at least got
Yeah.
something to go on. I can say, all right, this is if it's exploited, it's awful and it's likely to be exploited. I care,
Yeah.
versus it's not likely to be exploited, even though it would be awful if it is, or it's likely to be exploited, but it wouldn't be bad if it is. Those are things I care less about. But I do think there are frameworks like SSVC, if you're familiar with it, is a really interesting
Mhm.
framework. And that's, by the way, that is, I forget what SSVC stands for, but it's letter-wise the inverse of CVSS. And the idea is instead of having just a score and saying, here it is, it's a decision tree that says, is this being exploited? If it
Stakeholder
is,
specific vulnerability categorization.
thank you. The words were chosen to be an inverse of CVSS, but it's a
I didn't
decision
realize
tree
that.
that says, is it being exploited? If it was exploited, how bad would it be? What is the
Mhm.
asset context and what would the impact of exploit be in our environment? And so you end up with actual guidance that says anything from you must patch this now to follow
Yeah.
whatever your normal running apt get update, apt get upgrade every month is, or whatever whatever it is. It's a really interesting approach, and it's turning that on its head. And I'm sorry, you
And
you managed to get me off of what I was saying earlier, which was the prioritization is the first approach. And a lot of
yeah.
people have invested in that, talked a lot about it. What I find with prioritization is it merges those Venn diagrams of the 10% I can patch and the ones that I really should be concerned about. They're now overlapping much more, but it's not less effort. I'm putting more effort into doing that to get there. And so
Yeah.
that's why we've got to look at other approaches. And so what Patrick talked about earlier, I think, is the really promising approach, which is let's put less noise into this system. So
Yeah.
that 10% number from Scientia is not like a law of physics. It's not that you will only ever be able to patch 10% of stuff. It's that there's so much noise and friction in the system that you're having a hard time getting to that much. And so what
Mhm.
we're finding is, for example, in the container space, if we pull out all the noise in containers and have in it only what's required for something to run, we drop the number of vulnerabilities dramatically. And now what happens is all that investment we've put into finding vulnerabilities, prioritizing them, addressing them, becomes much, much more valuable because we're breaking out of all the effort to go through all of the things that don't matter, and we're focused only on what we're actually running, using, interested in. We've got far less to prioritize and manage, and now we're
Yeah.
much more efficient at it.
And if you can get that much more efficient, who cares about prioritization? Just fix everything, right?
Well,
You can kind of take a different approach to it, maybe.
yeah, I mean, I think the other piece to this is you don't necessarily, I think that's right. I think you don't necessarily have, like a lot of times when you take some of these approaches, you're like, well, we have to blow up everything we do. We have to go retrain
Mhm.
our operations team. We have to rip out XYZ product. And I think the reality is by taking this approach is actually kind of very different. I think fundamentally, this is beneath all of that is sort of a foundational thing. And so, you know, when I talk to folks, a lot of it is like, hey, you don't have to go retrain your operations team and your development teams and everything else. You actually can maybe see some of those things you spent all that time, effort, and investment in have a way greater impact on the organization in general, which, I think once you get some of that time back, you can then look at improving the processes and sort of get your head a little bit above water. But I think for a lot of folks, having this sort of approach is you actually can see some of the return on the investments you've already made, and a huge amount of security spend that most organizations are already kind of going through and seeing themselves still stuck in the basics of vulnerability management. And they've almost certainly invested in a bunch of products that have a ton of other capabilities and features that they were really hoping to take advantage of. But the reality is the majority of that time is still stuck in the very basics, and because there's a maturity curve here. But if you can just sort of get all that time back, and you don't have to go through this huge onerous retraining cycle across multiple teams and how they interact and redefining interfaces and everything else, I think that's a lot of things we kind of don't talk about. I think that's why teams can adopt new approaches, is because they can see some of those early successes and then start building on them and having a lot of confidence in kind of maybe taking a slightly different approach that doesn't require you to blow up everything you've already sort of built 10 years of doing.
Yeah. So one of the things, and I want to segue into what Minimus does, because kind of philosophically, I think it's unavoidable in kind of talking about the different approach here, how we're talking about shifting this approach. And this is something I've seen happen in the vendor space in general over the last couple of years, where people basically saying, it doesn't make sense for every company to have, say, detection engineering experts or threat intel experts or vulnerability prioritization expertise. Yeah. Like, there's just too many companies, right? And this is some of the stuff that's out there that you don't really need specific information about a company's environment to be able to add some value here, I think. And, like, for example, I think XDR was the first case where, some of these companies said, what if we wrote the detection rules for you? Stuff that, we see these ransomware groups, they're doing the same 10 things and having success with it every time. How about we build and manage those rules for you? So I think this is a good segue to get into talking about what Minimus is doing, because it's kind of sidestepping a whole chunk of the process here, I think. Outsourcing it.
Yeah.
Is the way
definitely.
I look at it.
Yeah, I mean,
fundamentally. Sorry, go ahead, Patrick.
No, Neil. I was going to say, I'll let Neil kind of take a swing at this, because I like the way he describes it.
We're both excited about it, but ultimately, what Minimus is doing is delivering minimal images. The clue is right there in the name, but we're delivering container images that are stripped of everything unnecessary in them. So I often use the example, if you look at the public Python image, Python latest on Docker Hub, it's built on Debian. It has 600 odd OS packages in it. And that covers, first of all, things you obviously need in a Python image. I need Python in my Python image to run Python. No surprise there. It has build tools that I probably need to prep it, but I shouldn't need to run it. So it's got a couple of shells. It's got wget and curl. It's got pip3 and all these other components that I need to build my image and get it ready to run, but I probably don't need in production when it's running. Yeah, exactly. And then there's like 560 other things in there that are just there because they're in the base Debian image and it inherits it. Now, when we build that same image, we build it with we build it from a distroless, a completely empty base image, and we put 23 components in it. So that's less than a 30th of what's in the public image. And so you get something that has fewer CVEs, it's more resilient, there's less for an attacker to live off the land. One of my favorite things, we've been doing some research and some work on the concept of mean time to CVE. And the idea being here, we often measure just in the number of CVEs in something. This has 100, this has 2, this is 50 times better, right? But if I ship something today with no CVEs in it, it's not going to remain that way. Somebody's going to find a CVE in the components in what I've shipped, And that's gonna trigger that whole cycle we talked about earlier, where I've got to go get a developer to fix it and rebuild it and retest it and reship it. So what we're
Mhm.
measuring also is if I ship something today, how long is it going to be before a new CVE gets found in that? And that's really a factor of how many components are in the image. What are those components? What's the history of those components? But what we're finding is like the public Python image is something like every 5 days. Every 5 days, it's getting a new CVE. When you strip it out, reduce it dramatically, it's not just that it has no CVEs today when you build it, it's that it's something more like 90 days before you find a new one that you're concerned about. And so that's great for that, reducing that churn of taking developers off of the work you're interested in them doing, getting them to patch things and test that and ship that. Now they can focus on features, they can focus on bugs. So that's what Minimus is delivering. Patrick, what did I miss
I
when?
would. I mean, I think you covered it really well. I think the other thing that we often kind of try to make sure that folks understand that it's the same bits that you're using today. So it's pulled from upstream. It's upstream sources. We're not going back and well, I say it in a not too derogatively way, but like rubbing some AI on it and hoping you end up with a predictable, consistent image that's over there. I mean, and that's the hard engineering work, right? The hard engineering
Yep.
work is looking and making sure that you have an eyeball programmatically to all the upstream sources that make up all the images we provide our customers and build it so you can do it reliably, predictably, consistently, and make sure that you have, from a compatibility perspective, it's the upstream bits, right? It is the packages that you're leveraging today that, in this example, Python's leveraging today that it needs. And so from a stability and compatibility perspective, typically, everything's just a drop-in replacement. And then we find that some organizations have some other dependent needs within their packages and everything else. And so those are the things that I think we've learned through doing this process that really matter kind of to the customers.
And I think
one of the things. Sorry, go ahead. Go ahead, Neil.
no. So I was going to say one last piece of that. One of the things that's interesting to me is this is not magic, right?
Mm-hmm.
Like I could explain end to end how we build images. You could go build this pipeline, but it's a lot of engineering, it's a lot of work, it's a lot of overhead. So it's probably not worth it for most organizations to build it on their own. It makes a lot of sense to go, this is something we're not good at. We don't want to invest in. We want Minimus's economies of scale to do it.
Yep.
But it's transparent. You can look at the images, you can see how they were built, what's in them, how they're composed, and go, oh yeah, cool, everything's here. This is what I need, without having to invest in that engineering yourself to do it.
So I was going to say one of my frustrations with traditional vulnerability management tools is that they don't really speak the language of the asset owners, right? Like if I tell you to go and fix CVE 2025 12345 on your iPhone, you're going to come back and tell me that's not how iPhones work, right? Like Apple chooses to give me an update. When they choose to give me that update, I am able to install it. And I don't even know which CVEs or security issues I'm patching here. Like I'm sure there's a web page somewhere I can go find that, but it's not useful to tell that person to go patch that CVE. Mm-hmm. And yeah, so instead of CVE blah blah blah, like it's always frustrated me that these tools don't say what you need to do is update your OpenSSL library or executable. Mm-hmm. And oh, by the way, updating to this version, here's a few changes, potential breaking changes if you use this these certain flags with it or something like that. Like that's what the asset owner actually needs to hear, actually needs to know, right?
Mm-hmm.
Yep. And I think that's kind of the answer there is where are you getting those bits? Can you get those bits and just put into something that you own and maintain without it going through a major distribution and everything else before like a sort of new image, and sticking with the Python or Nginx example, before that team has had the availability to update a minor library that may not be important. That's kind of one of the other advantages, the speed by which you can achieve a fix on top of the durability. And it's generally because it's software. It's, it's the hard work of making sure that you have the packages, that they're available, that where they belong, and that you can build as a result of it. It's a legitimate engineering challenge. I mean, you can try to magic your way around this, but most of the time in security, trying to magic around things isn't super successful because you need a predictable, stable, comprehensible output when you're trying to assess something.
And I think, Adrian, it's such an important point. I was talking earlier about how, developers are sort of a new constituency for the most part in solving security issues in cloud native approaches. I've been a longtime security person in my career. I work with a lot of security people. There have always been jokes about developers not caring about security. I've made those jokes myself. I'm sorry for having done so. But I think the honest answer is we often have not put good usable intelligence in front of developers to give them that, this is what you need to do, this is why you need to do it. We tend to do one of two things. There's no telemetry, no intelligence for the developers, but we expect them to secure things anyway. Or we overwhelm them. We run trivia in their pipeline and go, oh, well, there's 1,000 vulnerabilities in this container you just built. Do something about them. And one of the things I love about the Minimus approach, about putting less noise into that system, is what happens is it becomes a lot easier to engineer good telemetry, good intelligence, put it in front of the developers. Because what happens is, instead of having 1,000 vulnerabilities and 980 of them are coming from the base image, now you've got 20 vulnerabilities, which are all things in your requirements, in your dependencies, in what you're building. And so they all make sense. You can go, oh, okay, I've got version 1.2.3 of this library. I pinned to that because that's what I was testing with when I built it. I need 1.2.5. That's a minor version. I can go do that right now, not a problem. Or I need, 2.1, and that's going to be a set of work to figure that out. But it becomes a manageable problem with good intelligence in front of them, instead of something just that. If you put 1,000 vulnerabilities in front of a developer, the first thing the developer is going to do is figure out how to work around the security team.
Yeah. Well, it becomes obvious that it needs to be somebody's job to maintain that image, right? You can't keep using the image that was created 3 years ago and expect there to not be vulnerabilities. So then the question comes, if I'm going to outsource that to Minimus, and this is coming from a question in the chat, what is kind of the turnaround time there? If there is vulnerability disclosure, what is what is that process like when, because I imagine a lot of companies will have to customize that somewhat for their own dependencies, or I don't know if you do that for them, but how do you get stuff to customers and in what time frame, and how is dependency hell kind of handled with this shared responsibility here?
Yeah.
Maybe Patrick, coming to you for that one.
Yeah. Thanks. So we, and I kind of alluded to it earlier. So we've built the infrastructure to monitor the upstream packages and make sure. So, when there's a new version of zlib or GCC or something like that, we automatically detect that version. We grab the bits. If it requires compiling, we compile it, and it enters in from the Minimus side. It enters what kind of a pipeline really built to map that package against the images that's required. And all of that is sort of no man in the loop, generally speaking. That's the hard engineering work, is that instrumentation, that infrastructure to build it all out. So that's happening automatically. So there's a new version of a package that remediates a vulnerability. We're typically seeing it in a matter of hours, in building packages for it in the same time frame, and then building images that depend on that package continually. And we give the ability for our customers to pin to certain things, certain image tags, certain timestamps, major, minor, XY, Semver versions, etc. And so a lot of that control is in the hands of our customers. So it's not just they have to absorb everything we throw at them. They have the ability to kind of make that decision that's appropriate for either their business or the specific environment it's going on into, or the sensitivity of it. So there's a lot of control there that they have today. But by and large, it's typically happening in a matter of hours. And we do some things like we try to make sure we're ahead of like major releases. When Python 3.14 came out, we had it ready that day because we knew it was coming out. Those kinds of things, and because we try to look forward a little bit and try to understand the software that our customers are consuming to give them that predictability as well. But generally speaking, it's incredibly quick, much quicker than you'll find from any other source, simply because of the engineering effort that we alluded to earlier, the value of kind of putting a team of experts. This is all we do. We have a bigger team than almost any company in the world, focused exclusively on this problem to produce these artifacts for our customers.
And Patrick, I think Redis a couple of weeks ago was a great example of that. Mm-hmm. So in case, I'm deep vulnerability nerd, but Friday before last, there was a critical Redis vulnerability that was announced. CVE was published.
Redis shell, we're calling it.
Oh,
is that what we're calling it?
Celebrity vulnerabilities too, the ones that get named.
Yeah.
So, yeah.
And Monday, Wiz found that vulnerability. Monday, I think they published their write-up on it. And so I just went digging to see, what happened. And in fact, on Friday, we shipped an image with an update to it around the same time the CVE was published. Because the fix had already been checked into the Redis source, it was compiled, an image was built, and it was out the door. By the time people were looking at it to see, at the point they were starting to get alerts and starting to get news stories, the fix was already shipped in an image. It was there, ready, updated, and good to go.
And I think the other thing is we would have told you a new image was available and all this other stuff. So like there are the sort of the advantages to some of the platform aspects of it is our ability to have the visibility and then share that into the tools and systems you're already using. While I think often we've been in this world where we have some excellent researchers out from teams like Wiz and a bunch of other, like the industry built around this. And I think what we found on Fridays is everybody's almost always reactive, trying to understand impact and what do you do about it. The automation allows you to sort of short circuit a little while you live in this world of sometimes imperfect information, knowing that there is something available that you can move to. Is often kind of really helpful if you do have to react really, really fast. Mm-hmm. You're not waiting for the assets and the teams to go ahead and then it's going to go enter the vendor's pipeline. And, when does it hit Debian and when is that available? When are they going to ship a new version of that Docker image? And is that going to take 2 days? It's going to take 4, et cetera.
Well, it's interesting. I often talk about vulnerability management as 2 separate use cases. Right. And the one we're talking about here is almost like an incident response flow, right? Like you find out about a disclosure. It's something you've got exposed to the public internet. That's a very different process you're following than I need to pass I need to get my quarterly clean scan for the PCI QSA, right? Like that's the compliance use case, much longer times, much less stressful than these, we're seeing it exploited in the wild. It's 4 hours old, drop everything and fix it kind of workflow, and it's nice to have a partner to work with who's also scrambling, to get fixes out and stuff like that, that you can get some vulnerability intelligence from or some threat intelligence from, and it's going to help you get that fixed.
Yeah, absolutely. Sorry, go ahead.
So another good question
go ahead.
Another good question in here is how, the hardening piece of this, how do you get these containers reduced to just what's required to run and get rid of that extra noise? How do you identify and remove that noise? What does that process look like?
Yeah. Neil, do you want to take this one? You want me to?
Yeah, I mean, I think a portion of it is just engineering knowledge, right? It's working through what does this thing do, what's required, what's excess, and building that out. And on top of that is obviously testing, right? Unit testing to make sure everything works the way it's supposed to do. It does what it says on the box, and it's there.
Is there a kind of like debug tool for that? Do you guys actually have tooling where, okay, we ran it, you did your unit tests, and here's a list of all the stuff that you can just wipe out of this image? Like, is that how that works?
So A little bit. That's part of the engineering stuff that Neil referred to, and there's some commonalities across a variety of images, like language images as a thing go through a different sort of set of scoping and testing, and how do we figure out
Okay.
what needs to be built up from the minimum. I think we also have some advantages in terms of the realities of our customers, is they often need some tooling in the images as well. So we provide what we would think of as development versions of those images that'll have things like a package manager and a shell that will allow teams to leverage our images. And of course, we make use of those when we're testing images and working through scenarios like multi-stage builds and everything else. I think also, like, there's significant investment from maintainers of packages in testing and documentation to describe what their intent is, and we lean on their expertise as well. That's how you work through a lot of the compatibility and make sure that we're delivering something that's consistent and has the bits that came from that upstream package.
Sorry, Neil, I kind of cut you off, Neil.
No, it's all good. I couldn't agree more.
All right. So yeah, I kind of think of this as hardening, right? Like work that you can do on the front end to make things much easier for the vulnerability management team. Well, I often think like the vulnerability management team, a lot of their job, particularly with commercial open source, when you're running other people's software, is to tell you how well your remediation or patching processes are working. Like either they're doing pretty good, or this one's 4 years old. How'd this get in there? Right. Like something's unmanaged, something's broken in our process here. So it's almost a critique of the asset owner's process, right? Which I think is why it's so important to speak their language. So now that we've done this, Patrick, it always sounds like you have something to say here. So
well, I was just, you said hardening just a minute ago. And I know when you say hardening to Neil and I, that actually means a whole, like almost like secondary piece of thing. Neil and I have a very like shared history of working together. And I tend to think of hardening as, the configuration of the assets and reducing a surface area through the configuration, not just sort of the pull out of vulnerabilities in that practice, but it's really sort of the, how do you make sure the asset is.
I imagine you're doing both, right?
Yeah. And so like, that's a whole separate, distinct kind of set of activities and practices that we do. Hardening can be, does it need a shell? Does it need to instantiate with this user? Are we being
Can it be immutable?
Right. Do you need to have a level of permissions to open specific ports? Can you run this entity at a lower privilege level on the system? And so we think about a lot of that. And can you reference those hardening metrics against things like CIS or the NIST Special Pub 800-190? And we think a lot about that in the context of hardening. It's sort of so I get a little bit excited when we start talking about that, because it means a very distinct thing, I think, at least in my mind. And I don't want to ever speak for Neil, but I think he would probably agree with kind of like, oh, you said hardening, let's go on a riff about that for a while.
The idea that vulnerability management can be used as a scorecard and raise questions like that about more generally is another interesting one. So in 2024, I helped edit Orca's State of the Cloud report. And there was a finding in there that stood out to me to the point that I stopped all discussion and I went, no, hold up. So the finding was Log4Shell, which is a 2021 vulnerability in Java that was massive. Like everybody remembers December 2021 because everybody was doing nothing but going and finding where they had Log4j and everything. So in 2024 at Orca, they saw, I think it was 0.5% of all public-facing assets were vulnerable to Log4Shell. It's around 0.5%. And I was like, whoa, is that stuff that's been sitting there for 3 years unpatched? Or is this net new? And we went and sifted through a ton of data. And the answer was those were almost all net new deployments with a 3-year-old critical vulnerability in them, which I think really speaks to sort of the difficulty of vulnerability management in this space.
Yeah.
And as you've got all of this noise and all of these things going on, and you've got findings of pages and pages of vulnerabilities, how easy it is for even things that are dramatically obvious and concerning to slip through and make it into production. I do think
Yeah.
it's a clarion call to reduce the noise, get ahead of it, and get to where you've got
And
really concise, actionable intelligence.
it's a, that's where a lot of this dependency hell comes from, right? Like Redis. I think this Redis vulnerability we were referencing is one of these where a lot of people aren't installing Redis directly. It's some other package they're installing, and Redis is a requirement. And maybe the latest version of Redis breaks something with the package, so you get an old version, right? So it's carrying along some of this old stuff, and you got to have some way of detecting when that happens, and so you can try and find a workaround for it, because maybe with some of the software there's multiple branches that are managed at the same time. So maybe for this older non-breaking version of Redis, we have a secure patched version of that, but it's not the newest line.
And I think a lot of folks don't have a software bill of materials for the assets they're building off of and deploying. I mean, I think that's one of those things.
We found that out with Log4j. We found that out with Struts when Equifax got hit. We've seen that several times now, where finding a tiny Java library in a large corporate environment is very difficult because they don't have that.
Well, and I think a lot of tools that are used today don't produce it. I don't think you necessarily get that out of the box. And then if you do get it, I think some organizations are mature enough, they require some sort of provenance, so you can sort of assess where these things come from. There's also validation steps, and it's all like this. Everything's a maturity arc, right? And we've been doing this for enough time that everybody's on a different place on the maturity arc. But I think being able to deterministically tell what packages, what versions, what licenses, all of these kinds of things that are in your infrastructure, and they're feeding into the front end of the infrastructure, is becoming more and more important, especially as you start uncovering some of these newer classes of vulnerabilities or focuses on maybe application package manager vulnerabilities and the sort of the introduction there. If you're still trying to live with what's in your base images, and you're adding all that on top, I think it just sort of increases the complexity. Every single layer of abstraction, and the infrastructure we operate today is only just a stack of abstractions that just keeps getting another one tossed on and another one tossed on, and it gets just more complex every single day.
So working with Minimus is kind of a big change to how I manage software in my infrastructure, how I manage my my systems, my devices, my assets. How with customers, I'm kind of curious. Like, who are you working directly with? Are you working with the asset owners? The folks actually deploying the images? Are you working with the security team, the vuln management team? And how do these processes kind of change when you bring in some of these secure pre-built containers?
And I think I want to challenge you. I think it's often not a huge change. It's one of the things I like most about it is, and we have two types of images. One is what I think of as infrastructure components. I'm running Nginx, I'm running Grafana, these sort of things. And then it's simply a matter of changing which image I'm pulling to run in my environment, right? As simple as swapping out the Docker Hub Nginx image for the Minimus Nginx image. They're effectively the same software, just with far less noise in it. And then there are things I'm building on top of. There's Node, PHP, Perl, Ruby, Go, .NET, all of these things. Now, in that case, what I've got to do is change the source I'm building from. So in my Docker file, I've got from, library Python latest or whatever. Depending on how I've already built my Docker file and how I'm approaching it, it may be as simple as replacing that from image with ours. In particular, I find in Java that's most likely because Java typically uses multi-stage builds. There's lots of reasons why it's easy in Java. It tends to be a little more complicated with Python, but it's a one-time change. I've got to build the new Docker file that incorporates Minimus instead of whatever image I was using before. Once I do that, there's typically not a lot of maintenance and work. It's just I'm building from the new image. It's going to build the same way it built before, test the same way, ship the same way, run the same way, but have better outcomes. So
Yeah.
I do think it's typically a one-time investment in making that change, and then we're off to the races.
Yeah. I mean,
Now
and
the who. Oh, sorry. Go ahead,
sorry.
Patrick.
I was going to say,
No,
like,
go
you're
on.
still pulling from the registries that you're operating today. You can still tag the images in a way that's meaningful to you in that registry and everything else. As Neil mentioned, it's a sort of, I'm glad he kind of noted that, because it is typically a very simple change. Occasionally have some customers who want to go things like, well, we doing some weird sort of shell entry point. We don't want to do a shell entry point. So they will take the opportunity while going through this exercise to change some of their practices. But generally speaking, it's not a mandatory thing. Hopefully that helps. Sorry to interrupt you, Neil.
No. So to get to Adrian's actual question, the who is a combination of the security team who's already managing vulnerabilities and getting shouted at by developers today because they're throwing 1,000 vulnerabilities at them and they don't know what to do, and the developer and DevOps teams. So it tends to be, I would say, AppSec is sort of the new discipline that brings those things together. It tends to be whoever the players in AppSec are in the company that we're working with to build out the replacement, test it out, and then go for it. And I think, long term, so often we talk about things in terms of guardrails and paved roads, right? This is ultimately a paved road, right? We're saying, here's the thing that you can do that's going to improve your outcomes. This is the way to do it instead of that other approach. We're going to yell at you far less. And it becomes a virtuous cycle where developers are like, well, if I build on top of Minimus, I get 7 vulnerabilities and I can manage that. If I build on top of the public image, I get 1,000 vulnerabilities and I'm buried in that. So it becomes that cycle of making it worthwhile to make the change and then building on that momentum.
Yeah, so I imagine like I don't know, I tend to be kind of silly. So in my brain, I'm thinking about like a metric, mean amount of DevOps yelling reduced. Stop getting shot. I mean that is a good thing to note. If you're that kind of animosity, can go away, and you guys can start speaking the same languages, and you're not just throwing things over the wall. Yep. that's a positive sign to look for, I imagine.
But when we were building Twistlock way back in the day now, I guess, we saw the
I almost referenced Twistlock several times in this. I didn't know that you guys.
So it's sort of the code for this is Neil and I were a Twistlock and sort of have a lot of fond memories of the team there. But we used to talk about this constantly. He said, well, we know we're going to have to talk to security. We know we're going to be engaging with the engineering teams. We know we're probably going to be engaging in what we now probably call a security engineering, platform engineering organization. And so kind of sorting through all of that, it feels very, very similar. It doesn't feel like I think containers as a first-class citizen in terms of a kind of workload as primary selected has really changed, because when we started this, we weren't sure if Mesos was going to win, or Kubernetes, or Swarm, or Rancher, or anything in terms of the sort of the.
I've forgotten some of those names.
Yeah, you forgot. But back then it wasn't very sure, and so now
Rancher was CoreOS. Is that right?
Yeah. What was CoreOS? CoreOS might have had another one before they were bought by Red Hat. Can't remember.
Yeah. And that was before IBM bought Red Hat.
Right. So the industry has changed a lot, but a lot of the sort of, I feel like I'm having a lot of the similar conversations with folks trying to figure out, okay, well, we've adopted this new set of, sometimes set of constraints, sometimes methodology for deploying workloads and trying to take advantage of these things. But it's still always, at the end of the day, it's how well do teams communicate? How well are they using a common frame of reference? Are they talking about things in the same way? Which was a real challenge back then, and trying to get everybody on board. And I think you were still kind of working through that today, even with the industry, as much as it's matured. Back then, I do think the visibility problem was the unsolved problem. Once you sort of get past visibility, you really start having to actually fix the things you found. right? I used to tell people that if you want me to go find a problem in the infrastructure, I used to build big infrastructure. Well, that I'm not going to have any trouble doing that. I just don't know if you want me to go fix all the problems I'm going to inevitably find. So like, running big e-commerce infrastructure back in the day, it was never like, do you really want me to go look for that? Because I don't know if we have the bandwidth to fix the things that we find. So that we've kind of moved on from that today. And now we actually have the opportunity to start remediating some of these things.
Yeah, it's an interesting problem as attack surface changes. I one of the last vendors I worked for before I went independent was a SaaS security vendor, and that's how a lot of the conversations went. Like, CISOs would say, "Yeah, I know this is really important, but on my list of like critically important things, I've got time and resources to get through 10 of them, and this is number 37." Right? Like it's that. I don't even want to add this to the list of stuff I already have, right?
Yeah. Yeah. I mean, I will say the thing is, vulnerabilities in infrastructure is still probably one or two on that list, which is still a real problem that I think everyone has. And I think that's a lot of the excitement. Neil and I have experience, a lot of experience now with the largest CNAP providers, CSPMs, whatever. I think we're kind of putting them under today. And a lot of experience doing that. And I think what excited us both was about the ability to actually really fundamentally move the needle in a way that I think we mutually felt a little bit frustrated that we couldn't move for much of the last, 6-7 years of our careers. It's just, it fundamentally wasn't possible for us to kind of figure out how to take those big steps forward.
Yeah, I mean, a year ago, I was talking to organizations who had all sorts of cloud security goals, but they couldn't, they were still stuck on vulnerability management. They couldn't get to number 2, number 3, number 4 on the list.
Yep.
And so it's really refreshing to be able to help reduce the energy that goes into vulnerability management, get better outcomes, and free people up to go solve other problems.
Yeah, it's generally the thing I've found. I spent a lot of my career pen testing, and something I generally found is that people didn't need a pen tester to come in and tell them that they were missing patches, that they had remediation issues, that they had problems. I found what they really needed was guidance on how to fix all that stuff, right? Like better processes for erasing some of that stuff, because any tool these days, any pen test can create a giant laundry list of broken stuff, right? Now I think what people need is, okay, give me a strategy, give me a way to erase some of this stuff, not just a giant list.
Yep. Yeah.
Yep.
Wonderful. If anybody has any questions, we got a few more minutes, actually just 2 minutes left. So I'm about to land this thing. Maybe we could get one question in. But some great questions already. Thanks for getting those in. I'm not sure how to answer that last question here.
Well, I'm not sure I understand exactly which negative thing, because I will say also,
exactly. Like I need the negative things.
Security, I think everything's somewhat negative. Sort of, I think through a lot of the things we do is sometimes joke, or at least I joke, computers were largely a mistake. Sometimes it feels like, because, you're always on this treadmill, but, if there's a little more clarity on that question, I'd like to see if we can answer it, but
the answer could be lawyers, could be law enforcement, could be shift left. I don't know. I mean, that's one thing I find really interesting, about AI. Like, I'm really hopeful for AI finally, like the possibility to wipe out backlogs, that stuff every sprint that always gets pushed because it's just not quite important enough to make the list and to get done. But at the same time, like, I'm not sure how much that's going to cost. And if it's going to be, people keep talking about agents doing stuff while we sleep. And that sounds great until you wake up and the bill is 10 grand for yesterday's work. Right.
It's always a trade-off of costs, right? It's always, at the end of the day, we're generally speaking, everybody's trying to operate a business, and it's a trade-off between costs of X or Y or Z. And, going back to the original thing Neil said, is having a bunch of automated bug bounties or automatic patches submitted from the real experience of some folks in the community thus far is not super helpful in helping them close vulnerabilities in curl, et cetera. And so I think we're still in the very early days of all of this, trying to sort out what the real practical patterns of implementation are, which, again, going back to the Kubernetes and container example, we were trying to do back then too, trying to figure out what are the typical patterns of implementation, because it's all just sort of patterns and standards of implementation at the end of the day.
Yeah. Wonderful. Patrick and Neil, thank you so much for joining me today. This was legitimately just had a great time with this conversation. I think we covered a lot of good ground. Thank you so much for joining me today.
Thanks for having us.
Thank you.
And thanks to our sponsor, Minimus, for making today's webcast possible. And finally, a big thanks to the audience for joining us. Thanks for all those great questions, and we will see you next time.